Hey everybody, this is Gregory from Dapp University. So welcome back to this multi-part tutorial series where I'm showing you how to build a real-world crowd sale that can be used to raise real funds in a real ICO on the main Ethereum network. So check out the previous videos in this series if you haven't already, and be sure to subscribe to the channel to see the last video in the playlist whenever it comes out. This episode is presented by QuickNode, the fastest and easiest way to run your own Ethereum node. QuickNode lets you run a personal cloud-based Ethereum node in a flash without having to download any blockchain data or keep it in sync. Sign up at quicknode.io today to start running your own Ethereum node in no time. So in this video, what we're going to do is take the token distribution percentages that we created in the last tutorial, and we're actually going to, mint tokens for the founders and the foundation and the partners. And they're each going to get, 10% of this, total supply of the tokens, whereas the token sale is going to be 70. So let's go ahead and start doing that. The first thing we want to do is basically get the total supply of the tokens. So we'll say UNT already minted. So unit 256 already minted is going to equal, mintable token. I'll say total supply. Remember, whenever people bought tokens in the sale, it minted tokens for them. So however many have been purchased, that's how many have already been minted. That's the only tokens that exist so far, is however many have been purchased in the crowd sale. And if the goal is reached, then, that's how many have been purchased past the goal. So we can calculate the final total. We need to know the total supply of the tokens in order to, determine how many tokens the founders get, how many the foundations get, and how many the partners get. So we'll do that like this. We'll say UNT 256, final total supply is going to equal already minted. Right, this is this number. And we're going to divide that by this amount, the token sale percentage amount. All right. And then we're going to multiply it by 100. And we're doing that because, we don't want to divide by a fraction. So take the already minted tokens, divide it by the percentage, and multiply by 100. And that's going to give us the final total supply of the tokens. And now we actually want to mint the tokens for the founders. So now that we know what the final total supply is, we can calculate the tokens that the founders get. We could say something like, final total supply divided by the founders percentage. Right? That would give us the number of tokens that they actually get. And since we have reference to this mintable token, we could say mintable token dot mint. Mint. And, give it the founder's address or something like that. And we would just mint tokens for them that way. That's how you would do it. You'd say, hey, I want to mint this many tokens. Right, this many tokens, for this address, founder's address, right? So if you go to mintable token, we can mint tokens, for this address and this amount. That's what we're doing here, founder's address and this amount, which we calculated from here. So in order to do that, we want to actually pass in the founder's address whenever we initialize this contract. So we can do that up here. Let's go ahead and do it for all of the addresses. After goal, let's just say address founders fund, foundation fund, and partners fund. And we'll go ahead and assign those to state variables inside of the constructor. All right. So founders fund, foundation fund, partners fund, basically we're passing them in and giving access to those values inside the contract. So that's how we get access to founders fund. So we can do that like this, do that for all of them. And instead of founders, we'll say foundation, and then partners, right? And that's how you would mint tokens directly for these funds. Now, I'm going to take this a step further. Instead of, just minting tokens for these particular addresses, we're actually going to lock them into a time lock. So if you look at this smart contract, what it does is it basically says, this is a smart contract that's going to store the balance of the tokens. So we're going to actually, instead of minting tokens for the founders, we're going to mint tokens for a founder's time lock. And this is basically going to say like, hey, they can't touch the tokens for like 2 years, right? It basically keeps you from, running off with tokens really quickly after a token sale. This is a feature a lot of people want and request. So we'll just pass them into this constructor. What it does, it takes the address of the token, the beneficiary, which would be the founder's fund in this case, and the release time, which we'll say is like, 2 years or something like that. So I can add a time lock to this like this. I'm going to import it first. So after mintable token, we'll say token time lock. All right, that's all. And down here, let's actually create a time lock for the founders. We'll say something like founders time lock. We'll say new token. And we'll pass in the token, right? We have this address available to us, founders fund. Right? And then we need to have access to the release time. So we'll pass that into our constructor as well. We'll say, let's make this an unsigned integer. Because this is just going to be a timestamp, just like opening time and closing time. So here, I'm just going to add this and say release time. I'm just going to make this available as a state variable inside of our smart contract. Line this up so it looks nice. So yeah, founder's time lock is going to be this new time lock with the token, the founder's fund, and the release time. And we can do that for partners. Partners. And foundation. We can line these up to make them look nice. So founders, founders fund, foundation fund, and partners fund. Just making sure I spelled these right. All right, so instead of doing the founder's address here, I'm actually going to pass in the founder's time lock. That's where it's going to go. Same for foundation, and same for partners. So what's going to happen is, we're going to actually we're going to distribute the tokens based on percentages to each of these, and we're going to put them in a time lock so they can't touch them for a certain period of time. And that's what's going to happen whenever our token sale has been finalized after the goal's reached. So I know that's a lot. I took you through that pretty quickly, but let's write some tests to ensure that this works the way we expect, and hopefully it'll make sense of that. All right, so let's go ahead and write some tests for finalizing the crowd sale and checking the token time locks. We'll go to this finalizing the crowd sale example. We'll go say when the goal is reached, handles goal reached, we'll just continue building out this example all in one file. The reason I'm continuing to do this line is because I don't want this before each function to run and spend all this ether every time these examples run. There's probably a better way to do this, but I'm just going to keep building this out here for now. So what I'll do is basically first say that the total supply is what we expect. All right, so inside here we can write some tests. I actually forgot to add a test in the last example, the last video. Basically, I want to make sure that whenever this is finalized, that we can, the token's unpaused, and we can actually transfer the token. So we'll say await this dot token, transfer investor 2. So it should be fulfilled. So we'll just leave that there for now. That's going to pass. So now what we want to do is we want to test to see that, like, were these tokens minted? We'll have an expected amount. Like, so if 100 tokens were minted, and then we expect 10 tokens to be in a time lock on behalf of, investor 1. So actually, before we start that, let's go to the constructor and pass in some accounts and let's pass in some accounts for these funds, and let's also set a release time. So what I can do is go to the crowd cell config, and I'm just going to paste this in here. Say this.founders fund is equal to founders fund. This is going to be coming from here. So we'll say founders fund, and we'll say foundation fund, and we'll say, what's the last one? Partners fund. All right. So we're going to pull those addresses in, and we'll assign those to variables here. And we'll also say this dot release time is equal to the closing time plus 1 year. So we'll say they can't withdraw tokens for a year. And we'll pass these values in here. Actually, just going to copy this again. I'm going to get rid of these. Sorry. All right. So now I'm going to actually test for this down here. All right, it's going to be a little involved, but we'll try to walk through it step by step. First, I want to get total supply of tokens. All right, let's paste this in. So the total supply is going to be this.token.totalsupply. Right, we'll assign, we'll coerce this to a string. So what we want to do is get the address of the founder's time lock. I can keep track of that in the contract like this. Basically, we'll just say, we'll create some state variables in here like this. We'll basically just add these. So we're going to, all these state variables we've assigned down here, the founder's time lock, the founder's fund, and things like that. All these we passed in, we'll just make those public in the contract like this. All right, I'll save that. Go back to the tests. And yeah, the next thing we want to do is basically calculate how many tokens should be inside of there. We'll do that like this. So basically, we'll say, here's the time lock address. We're actually reading it from the crowd cell. Here's the time lock address. Here, because this is going to be created whenever the crowd cell is finalized. And then here is the time lock balance. We're going to say balance of from the token and pass in the founder's time lock address. And the founder's time lock balance, we're going to coerce it to a string. And then we're going to basically multiply it by a percentage. Well, sorry, we're going to multiply the decimals to convert it to a value that's like, human readable. And then we're going to say the founder's amount is a total supply divided by this dot founder's percentage, right, which is in the test. So the total supply comes from here, and this is the founder's percentage. So the founder's amount, we're going to coerce it to a string as well, and then also convert it to this. Basically, we're taking off like all the really small fractional decimals when we do this. So we do the same operation for both, and then you could probably refactor this into a function or like a helper or something like that, but I'm just trying to show you this. I'll leave that to you as an exercise. And basically we're going to say we want these to be equal, that the founder's time lock balance is the same as the founder's amount that we expect. So we'll save this, restart Ganache, and try to run the tests. Sorry, on the test. All right, it passes. So it's handling the goal reached correctly. Now what we want to do is, we'll do this for the partners and foundation and things like that, but let's continue building out this, and let's say that they can't withdraw from time locks whenever the crowd sale is finalized, right? So we'll do that like this. We'll get a reference to the time lock. So founder's time lock equals await time lock, right, at the founder's time lock address. We have reference to this token time lock, not yet, so let's import it. We'll say token time lock, right, just like the refund vault. So we'll go back down here and say founder's time lock equals a token time lock at this address, founder's time lock address. So founder's time lock release, that's when we try to actually, transfer the tokens back to the founder's address. So it shouldn't work. It should revert. So we'll save that. Go back to our test, restart Ganache, and run the test. All right, it passes. So now we can fast forward beyond the time lock period or the vesting period. And we can say, like, hey, after that's over, they can, basically, have their tokens. So we'll do that like this. We'll fast forward time. Oops. Fast forward time like this, increase time to this release time plus 1. All right, we kept track of the release time, which is a year. So a year later plus 1. We'll say founder's time lock release, instead of reverting, it should be fulfilled. So founder's time lock release should be fulfilled. All right, so we'll restart Ganache and run our test. All right, looks like there's an error here. Let's see what's going on. All right, I figured out why it's failing. I made a typo. Thanks for bearing with me on the typos, guys. This should be founder's fund, not fun. Sorry about that. And I keep making excuses, but it is incredibly hard to code and talk and think all at the same time, and teach, I guess. All right, so now that we fixed that typo, let's go here and actually test that the time lock release is fulfilled. Go to Ganache, restart it, and we'll run the test. So founder's time lock release should be fulfilled after a year, after we fast forward to the release time, plus 1. All right, it passes. So now let's actually check that the funds have balances. So we'll take the founder's fund, right? We've got track with the founder's fund here from the crowd sale. We'll basically say just say funds now have balances. Paste this in. So this will be the founder's fund, and we'll say the founder's balance. So founder's balance is this token balance of this founder's fund, right? That's what we pass into the contract. We'll convert that to a string divided by the amount of decimals, and now we'll say the founder's balance is equal to the founder's amount, which is the amount that was basically minted in the crowd sale. So now after a year, they have their tokens, and that's what we're testing for. And again, like I said, this is a lot of duplication in the test. I'll let you guys refactor this as an exercise on your own. But yeah, let's run this test and see what happens. So restart Ganache and run the test suite. All right, it passes. So now we basically want to, check all of this for the partners and the foundation as well. So I'm just going to go ahead and paste that in. So below founders, we'll basically just add some logic here. It says foundation. This checks for the same examples here. So the foundation time lock balance is equal to the foundation amount, and the partner's time lock is equal to the partner's amount. And like I said, there's still some duplication here. It's not the best, but it'll get you started. And same thing, we don't want the foundation or the partners to be able to withdraw from time locks. So we'll say this here. Yep, foundation and partners. And we'll increase the time, and then we'll allow them to actually transfer the tokens. Oops. Yeah. So they can release them. And once they've been released, now the partners and the foundation have balances. So we'll check for that. All right, we'll save that. Restart Ganache. And we'll run the tests. All right, that's it. It passes. So that's a really big test to check that the finalization function works whenever the crowd sale is successful. So yeah, guys, that's a lot of work. And we can see that we implemented all that here in our finalization function. That's going to be it for this video today. And that actually brings us to the conclusion of developing this particular crowd sale. What I'm going to do in the next video is show you how to actually deploy this crowd sale to a public blockchain so that you can actually hold it on a live network. So be sure to subscribe to the channel to see that next video when it comes out. And until next time, thanks for watching Dapp University.